So there's lots of different data types that I support, and we can see them here under tools constant. You can see everything from Boolean to color. If we bring some of these in, just frame that for a second. There's a Boolean value, color, integer, there's scalar, lots of ones. There's vector, 3D vectors, a standard vector type, and a matrix that is like your translation, rotation, or scale. And they're all signified by different color dots. You know, the matrix is a light blue, cyan style dot. You know, a scalar is a green. You know, integer is a dark green. Boolean is a kind of orange. Color's red. Vector is yellow. So these have different colors to tell you what's what. And if you try to link one to another, it may tell you type mismatch. And you can see the information here. You're outputting a scalar trying to bring in a single value or an array of 3D vector. So you can see what's coming out and what does it want in. Here you can see we're getting with color. You know, the output type is color, and the input type is scalar. So if we try to link the scalar in, of course, then it will work because those are scalar to scalar. Also, values have both per object or per particle. If we try to set some arbitrary value, you can see if it's per object or per particle. If I get rid of a lot of these, and I got a set data, and we link this into the ice tree. Just going to bring it over here so it's easier to see what's going on. We can move a little bird's eye view up and down. Just link this set data in. Just move it back a bit here. And let's get some of our data types. Let's just bring in a 3D vector. So right now you can see the data type going into the set data is black. Black means it supports any data type that hasn't been defined yet. When we link in our 3D vector, it will turn yellow, setting the set data to yellow. Let's give it a custom value. I just call it self.temp, and we can preview that by just clicking here, show values, and we just make sure it's set to numeric. Okay. If I hit play, you'll see a single scalar number at the bottom. If you want that to be numbers per point, we'd have to bring a per point value in as well, kind of link them together to get that value. So to do that, we can just do a get point position or particle position, are both the same. And then we can use an add or multiply node. See, let's just do a multiply node. Bring this one in here. There's several ways of doing this. I'm just multiplying it all by 0 to get those zeroed out. And now we can link this one in to the temp. Let's move all these out and preview this. And because we multiply them by 0, it shouldn't let all the values to 0. We'll just go right mouse button, show values, hit play, and now we can see they're all set to 0. Now if I want to change the value, I could do an add node, and I could add a value of 1 to the Y. Remember, this is a simulated ice tree, so it's going to happen per frame. So every frame it will probably add a number. Another one, if I hit play, at the moment it's just 1 because it's been set straight off. We could actually have the increase. The reason it's going back to 1 each time is because each time it's resetting it back to 0. If instead of the 0, 0, 0 multiply, we actually did a different system in here, you can actually increase this per frame. But that just shows you how you can make something per object or per particle by using, in this case, a point position. Other cases, depending on what you have, you could use different values such as age or anything you want, just to kind of give yourself a per point versus a per object control.